Hello everyone. I would like to give you a warm welcome on behalf of SGAC. My name is Mirta Medanic and I'm SGAC National Point of Contact in Croatia. For those of you who are with SGAC Webinar for the first time, SGAC is a global network of students and young professionals in the space industry. It is active for almost 20 years and it represents a voice of youth in front of the space agencies and big companies and also international bodies like UN Focus Committee. Can you hear me well? Because I hear some side voices.
It's the, I think it's the echo due to the fact that we have our microphone on.
Okay, can you mute yourself? Okay. Okay. One of the activities of SGAC are organizing conferences, and because of the global challenges. Because of the global challenges, we had to postpone the European Space Generation workshop until October. And to give you opportunity to stay engaged and to progress and learn, we decided to start a webinar series. And this is the first one from the topic Space for Urban Planning. So without further ado, I leave you with my colleague Ola, who will moderate the panel. We have today 4 panelists who will deliver the results of their project to you. I invite you to be active in the chat, and I wish you a great webinar. Ola, floor is yours.
Thank you, Mirta. The structure is going to be, as Mirta said, first we are going to present you the results. And please, you can mute yourself, all the participants that are not talking at the moment. Thank you. I'm Aleksandra Kozarska, you can call me Ola as well, and I'm part of the Space for Urban Planning project. Professionally, I'm a strategic and service designer. I'm also an ISU alumni, and I was one of the coordinators of this project together with Simone and Fei Dong, who couldn't join us today. Graziella Capelli was the chair of the project, and Leo as well was one of the participants of the project. So if you could introduce yourself briefly. Graziella, we can start with you.
Hi everyone, thank you for the invitation. I'm speaking to you from Australia at the moment. I have to say that it was my pleasure to be involved with an exceptional group of people who are the participants that actually worked on the team project. And I was just a facilitator, as a matter of fact, and I was very proud of them. All that they delivered. That presentation was fantastic. The report that they wrote was exceptional, and I hear that it was also presented at the United Nations. And I was very honored to be allowed to participate and work with them on that wonderful project. One point of reflection after so many months since the end of that program is that with the COVID-19 emergency, this project has become even more relevant than it was, because we cannot deny that lots of the challenges and possibly even the process that eventually led to the spread of the pandemic basically depend also on the way that that cities are built and the urban sprawl. That was one of the points of the project. So thank you for inviting me today.
Thank you, Graziella. Simone, can you introduce yourself briefly?
Yeah, good morning, good evening, or whatever time it's in your location. As I mentioned before, I'm from Italy, but I live and work in the Netherlands, where I'm a contractor with the European Space Agency, where I'm part of the team of the Human Spaceflight Division that handles the integration of payload, integration and execution of payloads on board of the space station on the European module Columbus. My background is space engineering. I'm a space engineer, and I did a PhD in the UK on navigation system. And I was part, like Ola and Leo, last year of the ISU summer program, and it was a really amazing experience where I had the chance to meet so many interesting people from different background and culture. So it was a really great experience. Thank you.
Thank you. Leo?
Hi everyone, so my name is Leo. I'm a student in France. I'm French. In Strasbourg, I'm studying biology, but I'm at the end of my studies, and next year I'll start my company. I'm a space entrepreneur, and I'm interested in how improving the health of astronauts by relieving, for example, anxiety by using smells. So really happy to see you all today, and I hope you will have a good presentation. Thank you.
Thank you, Leo. Thank you for the introduction. Grazia, if you would like to present quickly what is International Space University and what we were up to in the summer.
Yes, thank you so much for that, Ola. I am usually a professor by trade. I've been a professor for many years, but I'm not a member of faculty of the International Space University. Although I have been collaborating with the ISU in various capacities since 2014, initially as a guest lecturer, eventually as a co-director for the program in the Southern Hemisphere, and lastly as the chair of the TP project last year. So I have no authority to speak about the ISU, but I am very happy to do so in this situation, because even though I am not an alumna and even though I am not a member of faculty, I think we definitely can all agree on the main points and principles of the International Space University. They are shown here in this first slide. Basically, the ISU was founded in 1987. The vision was that to study, explore, and develop space for the benefit of humanity, and I'm sure we all agree about that. And the way that the programs are set up are based on international, interdisciplinary, and intercultural principles. These three principles of space education permeate all aspects of every program of ISU. So not only the programs are built around these concepts, but also the people who participate, both the people who are participants enrolled as students, and the teachers and the technical staff and the teaching assistants, everyone who participates in ISU programs abides and certainly subscribes to these three principles. A little bit of history. The ISU was founded in 1987, as the slide shows. It started its first program in 1988 with a 2-month space studies program. Eventually, the space studies program has developed into a 9 weeks program, plus 1 at the beginning, 1 week at the beginning for English proficiency, which is aimed particularly at participants who may not come from English-speaking countries or backgrounds. And it is held in different locations around the world, most often in the Northern Hemisphere, but there are 2 instances in which it was held also in the Southern Hemisphere. Then in 1995, 1-year Master of Space Studies programs was launched, and that's held at the central campus of ISU in Strasbourg. And eventually also a 2-year Master of Science in Space Studies, which also includes a final thesis, and an annual executive space course in Strasbourg, which has also been exported to other countries recently. I remember I have been teaching a couple of lectures also in the Australian program, which was held in November last year in Canberra as well. In addition to that, there is a very successful Southern Hemisphere Space Studies program, which is always held in Adelaide during the Southern Hemisphere summer. So to date, the Space Studies programs has been offered 31 times, with the last time being in Strasbourg. And it is very successful. There are more than 5,000 alumni so far, so there is a vibrant alumni community. And the success of the summer program has also foster the success of the Southern Hemisphere program, which started in 2010 and which has been happening regularly every year. Particularly relevant in this context is the fact that the Southern Hemisphere program is seen as a program for the Global South. It's only a 5-week program, not a 9-week program, but it follows the same principles of a live-in experience. And the reason why I'm particularly mentioning this in this context, considering also the audience of participants that we have at this webinar, I think it's particularly relevant. Many of the team projects, in fact, are aimed at solving problems from space or using space data. And we all know and are very well aware that the Global South is in a state of particular development now, where new technologies and space data can actually solve very important problems. So that's why I decided to spend a little bit of time mentioning about that. Coming back to the Space Studies program, it's always built around 3 weeks core lectures. These are the initial intensive lecture programs where lecturers from all over the world actually are invited to deliver knowledge within their area of expertise. These 3 weeks of core lectures and workshops are then followed by a 3-week length of departmental activities where the participants are able to do professional visits, go visit observatories, research centers, and interact more with additional experts who also guide them through an individual project. And then in many cases, these individual projects become the focus or feed into preliminary studies that then enrich the final team project that is held as a capstone at the end of the program in the last 3 weeks. So I was fortunate enough to be a chair of one of the team projects last year. And with this, I think we can introduce the project now, Ola. Thank you so much for paying attention to me.
Thank you, Graziella, for this introduction. Now just quickly, briefly mention all the other projects that we had last summer in Strasbourg at Space Studies program. So one of the 4th project was Fast Transit to Mars, exploring propulsion systems that enable us to go faster to Mars. Enhancing industrial space competitiveness was the 2nd project, so focusing on the Grand Est area. Space for urban planning, which is the one that we are going to talk in detail in this presentation. And the last project was Next Generation Space Systems Swarms, so exploring application and potential use of intelligent swarm constellations. So if you are interested in any of those projects, you are very welcome to go to the ISU library website. All the materials are available there for free. Going back to the topic of our presentation, which is space for urban planning, the team project that we were working on for the last 3 weeks, as Graziella mentioned, of the Space Studies program, was facing this challenge of investigating the impact of space technology and applications on urban planning to achieve a more sustainable future for global society. And as Graziella mentioned, these projects and the whole philosophy of ISU is based on being a very multidisciplinary and international participation of people who are part of this program. So in this case, our project consisted of 30 participants coming from 16 countries. So you can see it was very much in the spirit, in this international spirit of ISU. This is a picture of our team. You can see it's very diverse, coming from various backgrounds as well, not only from various countries. So it was a very interesting mix of a group of people, and it worked really well together, which hopefully you can see in that presentation. And this diverse group of people was presented with that problem. With the challenge that urban growth is proving particularly challenging for cities and raises the question of how to reassess the traditional approach to urban planning. And why is it important, and why is it important now? Because at the time as we were analyzing this project, in 2019, 55% of the world population was already living in the cities. And some countries like Canada or Brazil actually were already over 80% of their population living in urban areas. And this number worldwide is estimated to increase until 70% in 2030. So this, what does it mean? This means there's a growing pressure on urban areas, and especially when we consider on the resources of the urban areas, because resources are not infinite, and this is the focus that our team took in this project, to focus on the resource management within the urban areas using space technologies. And in particular, we decided as a team to focus on these 4 areas of resource management. So land, and we were exploring the challenges of the land related to urban sprawl and urban lands and urban growth. So things like soil quality and property, land use, insufficient infrastructure, and also natural disaster management. From the energy side, we are analyzing challenges such as poor energy consumption, low energy efficiency, or energy waste, for example, and energy production, alternative ways to produce energy. And of course, the greenhouse gas emissions as well. From the water challenges, we were exploring, of course, water scarcity, limited amount of space-based hydrological data, water treatment techniques as well, and lack of sustainable water systems, for example. And from the transportation point of view, which we also called time internally in the team, we are exploring challenges such as traffic congestion, loss of public space, increasing commuting time, but also road and safety topics and roads and safety hazards caused by human error. In addition to these 4 areas, which later were divided into teams who were focusing on these particular topics, we had also 2 teams focusing on urban planning, so history of urban planning and urban planning trends, as well as social, economical, and environmental impact of those challenges, and later of the solutions that we are proposing. And with these challenges, we envisioned an improved urban growth model that reassesses the traditional approach to urban planning to reflect sustainable development goals through a better resource management. And well, in this project, we will also try to address the sustainable development goals, and we made an exercise of understanding which sustainable development goals in particular we are answering with this project. So you can see our results of our analysis here. And of course, the mission to answer these challenges and to attack this vision was through the space technology and applications towards achieving a more sustainable future for global society. And this is important also to point out that, as we are hearing before from some of the comments of the participants in this webinar, it's very common to look at these challenges from the space applications point of view and, well, satellite-based technologies. But we also wanted to include another vision and include, let's say, all space-related technologies, not only space applications, so also technologies derived from human spaceflight or other technologies that can be used conceptually in this area of urban planning and urban development. This is a very complex challenge, as you can see. It's a very complex problem, and one of the ways to approach such complex problems is to use a design process that can help us in a short amount of time, which definitely was to address such a challenge in 3 weeks. So as a team, we decided to approach this using a design process, which consists of 4 phases. So we are discovering the challenge in the context that we are presented. We are defining the solutions, exploring and defining the solutions that we are going to use, developing them, and finally we are evaluating them. So we have these phases of divergence and convergence, intertwining, and towards more feasible solutions at the end. And one of the key points of this process was a future vision workshop that we did in the middle, more or less, of that process. And it was a milestone for our team because all together, you know, we were split into teams to work on these challenges, but this was the moment when we came all together and showed what we were researching until this point. We also switched the challenges, so we could also think a little bit outside of the box and think outside of the challenge that we are having and help other teams to have another perspective. We were brainstorming all the solutions, and we were mapping the solutions to choose the ones that we believe have the most potential to work forward. at the end, we envisioned the future cities that are supported by space technologies, and we built scenarios to visualize these futures. So this is a little bit of summary of the solutions that the teams were coming up and the common trends that were appearing in these solutions. So as you can see, some of them were pretty much more, let's say, in the near future that could be feasible. So for example, a lot of teams were addressing challenges, or the solutions were addressing the challenges around tackling climate change. Some of the teams were proposing moving away the industry out of the cities. There were a lot of ideas as well of connecting of the ground and space-based assets. And later on, there was a lot of ideas based on the use of data and AI and algorithms, smart resource management as well. All of this was very important to have in mind as well global and transparent governance to introduce this kind of technologies. And later on, we had also more, let's say, transformative ideas towards a more, let's say, further future and transformation scenarios. So even moving away the industry into the outer space, which is, we know, is one of the things that is very popular topic at the moment as well to talk about. And new landscapes inspired by space habitats. So for example, we were using here the concept of closed loops and how we can apply that into the new landscapes in the urban areas. So it's like more further in the future as well. These are the 18 solutions that came out of this project. As you can see, they are divided into the land, water, energy, and transportation areas, so responding to the challenges that these teams were tackling in this project. And as you can see, it's a mix, as we were saying, of space applications and space-related technologies in another sense. Like, for example, in land, we had the technologies that the team considered that they have the most potential for the future is, for example, land use cover change analysis, soil health status card, geotagging urban assets, or flood monitoring systems. So you can see that here they focused more on the satellite and space applications technologies. In water domain, we had a little bit of a mix. So we have, for example, real-time Earth observation hydrological data, but also, for example, water recycling plants, which is the concept coming from closed loops and how can we recycle water in a more sustainable way. Energy team decided to go into a little bit further future in some of their solutions as well. So on one hand, we have radiative cooling of thermal insulation control, which is also used in satellites, but also third generation solar panels or solar power satellites, and the way how the energy is transmitted through microwaves from the satellite generating the energy to the ground. So there's a mix of solutions, as we said, from looking at these problems from different angles. And the transportation team was looking, well, also into topics like traffic policy regulations, but also a lot into data and how data can help us manage the traffic, and also looking into technologies as autonomous vehicles. So taking, for example, solutions from robotics and autonomous vehicles in space and how we can use them here on Earth for better transportation. If you have the point of this is I'm not going into technical details of any of the solutions right now in this presentation. All of this is documented in the report as well. If you have any questions specifically about any of the solutions, we can also answer them in the Q&A at the end of the session. The main message here is the project that we did is sort of a benchmark of these technologies and the technologies that we are considering that they have the most potential. In order to come up with these conclusions, we made an analysis of well, social, economical, and environmental impact of each of these solutions, as you can see represented in this slide, as well as the success rate, which is the sum of impact and feasibility factors, so technology readiness as well, and the impact that technology is having. So this is like a summary on a high level of all these solutions analyzed, and yeah, just making a benchmark and an overview of the technologies that have potentials to use in the future in this vision of future city from the point of view of our team. However, as you can see, a lot of these solutions are also based on data. So one of the very important topics that we are tackling as well, and one of the teams on our project was dedicated to that, is to develop guidelines for the local governments, policymakers, and stakeholders in order to make sure that some of these technologies can be implemented in a more transparent way on the local level as well. And Leo is going to present you more details about the guidelines. Leo?
Thank you very much, Paula. So what you've heard already is that we try to investigate how space technology can solve problems. And after all this thinking, we decided to formulate recommendations for urban planners to achieve a more sustainable future for our global society. The premise of this project is that all 4 pillars of sustainable development, as described in the Space 2030 agenda of the UN, had already been fulfilled. So the main findings and recommendations are displayed here on the slide, and it's take the form of a guideline providing a framework for enhancing the design, development, and implementation of urban projects by leveraging space data and technology to design inclusive, integrated, and resilient cities. An effective implementation of urban project is based on the assumption that such processes are supported by an appropriate legal framework, adequate investment opportunities, mechanisms established to manage cost effectiveness, and suitable political support. So here in this slide, you can see all 12 guidelines, including informed planning, social consideration, sharing expertise, collaboration, transparency, monitoring, cost assessments, sustainability, connectivity, quality of life, knowledge support, and of course, planning for the future. So I'm not, as Ola said, going into too much detail about all of those points, but there's not much, actually our summary contains a really small summary for each point. So if you're interested in it, it's not really long to look at, but I'm just not gonna tell them right now. So we present this project hoping that our recommendation will be implemented by urban planners, and we believe that cities of the future can be sustainable, accessible, and progressive. So please, if you're interested in, take a look at it, and thank you very much.
Yeah, and all the resources and the project and the executive summary as well with all these materials is available on the ISU library website. I think we're also going to share the presentation with you, this presentation, so you will have all the materials available. And yeah, so at the end of the project, we did also a little bit of recap. We did a presentation to experts on the topic, and it was a great conclusion of the project as well, because it enabled us to actually visualize this future in a, let's say, body storming and acting way. And big shout out to Nikita here, who did a great job on coordinating this final presentation, which is quite an event and quite an adventure itself during the SSP program. Okay, so we saw the results on high level of the project, but this was last year that we are working on that project, and right since then there were a lot of things happening in the world. As we can see right now, the context is quite different because of the pandemics. So we were also considering how space technologies and how these questions that we are raising and how does it impact and how can it help with emergencies as we are experiencing right now, like pandemic, and especially in relation to urban areas. So Simone now is going to present you with some results from the European Space Agency and some actions from the European Space Agency that were working on that particular challenge. Simone?
Thank you, Ola. So yes, it was impressive how actually some organization reacted to this situation, this pandemic, and it shows how actually we have the resources and the capabilities to implement sometimes even easy solution on based on what we already have. ESA during this pandemic situation made a call for ideas on how space technologies could help to reduce the impact of this type of pandemics. So the challenge itself, ESA identified some of the challenges that in the world we were facing, like shortage of supplies, medical supplies, particular like ventilators, validation, how to validate some solution generated by amateurs or even companies that before putting in place you actually need to certify before you can use. As I mentioned, a shortage of some supplies then show some deficiency and problem in the logistic and the supply chain. So this, you can see there are some of the example of the challenges that we faced during this time frame. You can go to the next slide. Yes. So ESA gave a very short time frame actually to its own employees. Gave only 2 days to come up with certain ideas to how to support this kind of situation. And in only 2 days, 138 ideas coming from all the different ESA sites were proposed, out of which the main 16 were chosen and divided in 3 main categories. They were in donations, e-learning, and telemedicine. These ideas were evaluated under 3 different criteria. So relevance, so how much this idea could support in the short term the need of during this pandemic. So the feasibility, so how fast can this be implemented, and the impact of what are the main results of this concept integrated. I can tell you that I give some looks to some of these ideas because they are available for us to look at, and they choose these 3 main categories because probably they are the fastest to be implemented. But there are also other ideas on how to support 3D printing, how to put in place the technologies and facilities ESA has, like also, as I mentioned, to 3D printing ventilators, or how to sterilize used equipment quickly and more efficient, and also to reuse the same equipment without trashing and generating more demand on that. So it was quite impressive, and ESA is going to implement these 16 ideas. And this is an example of how in a few days, this all happened in a few days in April, how actually we have the technology in many cases, but sometimes we don't realize that we can use also for other purposes. So this shows us that we need to also open more our mind and think ahead and use what we already have technologies, and that's also what we did during our urban planning project. We analyzed what kind of technologies were available and how they could be used implemented on a daily basis for other needs. And that's it. Thank you.
Thank you. Yeah, exactly. So the technology transfer is a very important topic here as well, having in mind how can technologies be used maybe in other uses in this case to fight the pandemics as well. And that will be it from our side. We are very happy to take any questions that might be appearing from you and just opening up the discussion. Thank you.
Interessant.
Mirta, do we have any questions or?
Can you hear me?
Yes.
Okay. So until now, we only had a few questions and comments in the chat with regard to availability of the materials after the webinar. So again, this webinar is recorded and the recording will be available on the YouTube chat. And also the result of Ola, Simone, Graziella, and Leo's project is a full report and the executive summary that are available on the International Space University website. And after the webinar, we will share all the information how to get all the details. And now I open the floor for specific questions with regard to the project. So feel free to either write it in the chat or raise a hand and speak up.
All right, just to answer a very quick question that just appeared. The question is from Abdo. Hang on, from Gabriel about online courses. So as a matter of fact, this year the Space Studies program cannot be offered because obviously it's a live-in program where everyone works together for 9 weeks, 24/7, and no one can travel, and certainly no one can live together at the moment. So this year, the International Space University is developing what they call an interactive space program. It's going to be a 5-week program completely online. And they actually have already a web page. If you go to the ISU website and select programs, there is a list of the program. And this ISP is the latest program developed. It's offered this year for the first time ever. I'm not sure whether when the SSP can be offered again after the COVID-19 emergency, the ISP will be kept. So this will be an experiment. But as far as I understand, they were still accepting enrollment, and the enrollment link is obviously online. So if you just go to the ISU website and click about the information on the ISP, you should be able to see exactly how they are planning to structure this new program, and it's completely online. Again, Gabriel has the question about the requirements for being accepted. So as far as I understand, it's open to all university graduates and professionals, regardless their background and the professions they work in, because the principle again is follows the 3 I's of ISU. So the program is open to everyone from any background who is qualified in terms of having a university degree or already being a professional in any discipline, because as we all know, space needs everyone, not just scientists and engineers, lawyers, architects, artists, everyone is welcome. So there will be certainly more information on the website, but I strongly encourage anyone who is eligible, i.e. who already has a university degree or has been working already in industry or in any sector professionally for a number of years, to contact the academic coordinator, who is Alex Ryan, and all the links and contacts are also on that web page. So this program, of course, being online, will not be a living program, as I mentioned already. So everyone will not be traveling to a common location like it normally happens for the SSP, but there will be attendance requirements. So it will be considered to be a full-time program in which people are supposed to be working for 5 weeks, 9 to 5. From my understanding, the ISU is organizing 3 potential time zones that will reflect the idea of a mission that runs with handovers from Earth orbit, Mars, and Moon. So that's the scenario. And so to allow people from all over the globe to actually do their 8 hours of work in their own time zones, with 1 overlapping hour where the teams will all be together, come together and hand over the work that they've done. So it's very imaginative. It's certainly quite complicated in the way that it's going to be structured, but it's certainly something that reflects more of how missions are actually run. As you all know, space missions run 24/7 with people around the clock in different shifts. So the idea is to have 3 different shifts, but with the engagement and commitment that everyone who participates commits to a full-time schedule for 5 weeks. There is a question about the cost of the program. I don't have those numbers. There will be information again on that website. I am not directly involved in this new iteration of the program, as I was supposed to be chairing the Department of Science this year if the space program was going to run in China. That's obviously no longer the case. So because there is now a much reduced scope for the program that's going to be offered online, I felt that I could not certainly participate and contribute very much. So I'm not directly involved, but I know what's been discussed, and the information also about how much it's going to cost will be online. But I encourage everyone who is interested to contact the academic coordinator, Alex Ryan, because traditionally there have also been scholarships awarded for all of the ISU programs. So you never know. The only way to know is to make contact directly with ISU.
If I can just add something, Graziella. I am directly involved. I'll be a TA, and it's not anymore TA, it's officer in this program. So if you have any other question, you can also reach me, and I could put you in contact with Alex Ryan if you're still interested.
Thank you, Graziella and Leo. Leo, you can also share your contact in the chat so people can reach to you. And there were a few very interesting questions from attendees. One was from Abdo. He asked more information about the technology transfer. And there were a few with regard to the urban farming and urban agriculture. So who would like to take that?
Can I elaborate a bit on my question, if possible?
Of course, yes.
So I thank you very much for the presentation. It's really great, and the work that you guys have done. And what I really like the most about your work is that you did not only focus on using satellite data for urban planning, but you also talked about technology transfers, using space technology for that as well. So transferring the technology in that direction. What I was asking about is that especially developing countries or communities that don't immediately have access to space technology, was there a little bit of a brainstorm on that and how to make that available? So to transfer technology in that direction. So ESA, of course, for example, is a great place where this technology lives. But if I am in Cairo, where I come from, and I would like to use such technology, for example, for urban planning, was there a discussion about having such platforms available for people to access that in order to use it?
I can cross-check. I'm pretty sure, like, just make an example I was reading a few days ago. There is one program, I'm not sure if people are aware, it's called Melissa. It's a life support system designed for Mars or planets, so for colonies on other planets, and it's supposed to recycle 100% like of the water. As far as I know, this technology has been already implemented also on Earth. There is a university in Morocco, if I remember well, that had access to it. I'm not sure if it's a prototype or a different version of this Melissa system, and they're actually using for the local community. So I can try to contact the, I can give you my email address, we can be in touch and try to understand how the University of Morocco managed to get this information from the technology transfer from department at ESA. So we can check. I'm not aware that, I know there is a department in ESA that's called technology transfer. So there are people working on how to help support local companies or entities that would like to introduce this type of technology, developing space, but can be used on ground. Then we can see. We can be in touch. I will we can be in touch afterwards. I can give you my email address and we can be in touch.
Perfect, thank you.
I'll just mention that for the purpose of this project, and because of we had to narrow the scope at some point, we also assumed that just for the purpose of this project, we assumed that the space data is available to all the countries. That was our assumption, and these ideas are kind of space, let's say, location agnostic in that sense. But that's a very good point, and we had discussions about that. Just for the purpose of this project, we decided to make this assumption.
Yeah, I would like to add that yes, we were forced to narrow the scope because all the participants only had 3 weeks to actually study all the material, summarize what was important, come up with the plan, implement the plan, provide recommendations. And clearly, with this kind of problem, every single aspect of urban planning is a discipline in itself. And therefore, it would need development of its own project for each one of those aspects. Therefore, having narrowed the focus, we had to start with some assumption. And the assumption was that we were imagining a society where space was accessible to all. And by accessible to all, we don't mean just capability to get into space, but also those countries or those communities that cannot get into space can get the benefits of space from getting the data and getting the technology developed by other countries, for example. So we were assuming a kind of ideal world. We, however, kept asking the question anyway as to whether space is generally and really for everyone or not. And in fact, there is a section in our report that addresses space and society, in which we also wonder what needs to happen in order to make sure that this premise that we had, in fact, actually occurs. In other words, that space is accessible to everyone on this planet. So I encourage everyone who is interested in reading the full report, because there is also this food for thought kind of thing. And I think that that was one of the reasons why it was proposed for this report to also be presented to the United Nations. Now, obviously, in 3 weeks, we cannot solve the problems of the universe, but if you are thinking about sharing technology, Simone has already mentioned ESA has some programs for sharing technology and giving access to important technology outside of the ESA program, so to countries that actually don't participate in ESA. If you're thinking in terms also of getting data and analyzing data, there are programs that are available to everyone, and I'm thinking specifically to something that I have explored with one of my former PhD students who was doing health work in Papua New Guinea, who thought that it would be very useful, particularly in developing tools to trace the spread of zoonotic diseases, how we were able to actually provide the data and the analysis tools to those communities using OpenGIS, for example. So there are a number of initiatives in the world. Some of them are run by the University of Oxford as well. And those tools may not be specific to the problem that one is trying to address, but they can certainly be transferred in terms of addressing more problems than they're actually developed for. So in that context, perhaps if that is something that you might be interested in with your question, or your question was leading to that, you can shoot me an email and we can progress further on that. I can provide some links of material that can be used to further develop onto your question. So just let me know.
No, perfect. Thank you very much.
There's a very interesting question from Ming. Actually, that's a very, I'm just going through again the 18 solutions. It's difficult to say because these were mainly related to urban planning, but I think a couple of them can be very useful to tackle the pandemic. like the one from geotagging and mapping infrastructure and assets. This could be helpful to understand in cities, which areas are they don't have access to specific facilities like hospital or in any case any medical care. Reducing the time between a person needs to go from their own home to the hospital could save more life if everything is well distributed in the city. The other point could be the sounds a bit strange, but the technologies to reduce traffic, or in any case to understand the flow of people in the city. So if you manage to understand which areas are the most crowded in terms for public transportation, you can try to understand which area could be mainly impacted. Because if you have a higher concentration of people taking a specific, I don't know, underground line or bus service, then you have a higher chance that in that area this could spread faster than you think. Does it answer your question? This is what I think could be a couple of examples of what could help.
So you say, Simone, to use space technologies to calculate the best routes to move people, but also goods and services in cities when there is a very big pressure and where it's very important to not to have conjunctions.
Big cities have, of course, some lines that are more used than others, and if you know that these lines are overcrowded already at a specific time, and there is the risk of this pandemic, either you can take measures to try to increase the service in the area, so trying to dilute a bit the crowd and everything. But this you need a system that analyzes your traffic or the level of people taking the public service. Mm-hmm. Oh, you're welcome.
And what do you think about urban farming and urban agriculture? Because now in the time of pandemic, we realize what is really important and what we need every day, and that is food. Do you think that something can be done with regard to that, or are some areas on the earth already are doing good can show good best practices for urban agriculture, and are they using space to maintain that?
Well, some of the solution proposed was exactly like land use and management, with the support of space technology, so remote sensing. And the solution proposed was to use this data to evaluate the land use, and so which area can be used for agriculture, which one for building new neighborhood or facility industries. So on one side, it's the question still related to pandemic. Sorry, I lost this part, or in general?
In general, I think it was in general about urban farming data and agriculture, urban agriculture. So producing food inside of the cities, I think.
Oh, inside the cities. Yeah. Okay.
Yeah.
In urban areas.
Yeah, it's interesting because I heard, so Australia is lucky to some extent. It's a large island, and if you stop people coming in, you can, more or less be feeling kind of safe. But of course, this wasn't done at the beginning. So we've had our spread of COVID-19 recently. And I know of friends of mine who actually started cultivating their own backyards and planting plants so that they can have fresh vegetables. So definitely there is a scope for urban agriculture. In order to assist when the pandemics are already there. But I would say a little bit more than that, actually. And it's the fact that often these kinds of emergencies, such as a pandemic, but not only, occur when you have environment fragmentation. And this usually is caused when you have unfettered urban sprawl, urban growth, which is what we have seen in many, many countries in the world. When you have more traditionally built cities or urban centers, they generally are sustainable. and there is usually good spacing between activities. There is more controlled traffic. When you have urban sprawls, when you have unfettered growth, that's when the problems actually start. That's when you have the needs, also technological needs, to manage that growth, and that is where the difficulties arise. So in those kinds of situations, all the data that you have are necessary, and data from the ground as well as data from space, technology that is developed in space for people who live in very constrained and small habitats should be deployed also to solve some of the problems on Earth. I think that one of the things that I liked, one of the solutions that I liked very much in the TP report, and that was written in the report, was using the material that the spacecrafts are built on as thermal insulation material, in order to bring down the thermal exchange between buildings and atmosphere on Earth. And that is something that certainly helps with the environment, but could also help in terms of energy balance with urban agriculture as well. So there are a number of solutions out there that have been implemented and developed for certain specific problems, but that are certainly transferable to an urban environment, and that can be helpful also for urban agriculture.
Mm-hmm. Thank you, Graciela, and thank you everyone for submitting their questions and being very active in today. I hope we are come to an end of this session. Thank you everyone for being here. I hope that we will continue the discussions after the webinar as well. Follow SGAC social media and website. We will publish materials from today there. Maybe we can do a wrap up with some closing words from our panelists. Would you like to say a word before we end?
I'd just like to say thank you to everyone and to all the participants for very interesting questions. Of course, this project was short, was very intense, and there are still a lot of things to explore. But as we said, it was a benchmark of technologies, and each of them could be explored even further. It could be a project or a company itself. So hopefully this overview brought you some interesting insights and for further discussions in the future. Thank you for this opportunity.
And if I can mention, since now Ola has mentioned for the development of all of these questions that we have left open because of lack of time, and also because, quite frankly, we were a quite varied group of people with so many different expertise, which on the one hand was very useful because in that way we thought of many different problems being together, but on the other hand also prevented us from selecting solutions that are implementable in the real world by experts specifically in that field. So it would be nice to see this project continue on those different questions with the collaboration of people who are working in urban planning, perhaps now on Earth. And I'm pretty sure that the members of the team were very open to continue collaborations in the future. So if you guys know of anyone or any company or government or policymaker who would like to explore some of these issues with us, I am pretty sure that we have a very enthusiastic team of people with varied backgrounds who would not shy away from learning new things and who can provide new and different perspectives to the problem. So please contact us if there is something that you can think of and we can help.
And also, if I can just add something, we see now with this terrible COVID-19 pandemic that there were really two ways to deal with the problems. It was the people that live in the countryside who had access to nature, urban areas, sometimes a garden, and people in the city. And we really are all witnessing how life are different when there's pandemic, with this habitat changing. So I really think that this example of one of the worst things that can happen, is really showing us how much important it is to think urban planning, and it will be more and more important as more people are going to move in cities, because we see that it was terribly complicated for a lot of people. So I think urban planning is really something we will more and more take in consideration when doing any building.
Well, we came to an end of this webinar. I hope you learned a lot. I hope that we will all stay in touch, follow SGAC and International Space University online, and we will see around. Thank you very much. Bye.
Thank you.
Bye.
Thank you. Bye.
Thank you. Bye.